All right, welcome back to another Advent in Code, day 15. Okay, so if you remember yesterday, I said that we were going to pre-solve the problem just to make sure that I had a working solution in mind. Keep the video shorter, and we're going to jump straight to the how-to. So let's first explain the problem, and then let's explain how to solve it. Okay. While you wait for your flight, you decide to check in with the elves back at the North Pole. They're playing a memory game and are ever so excited to explain the rules. In this game, the players take turns saying numbers. They begin by taking turns reading from a list of starting numbers, which is your puzzle input. Then each turn consists of considering the most recently spoken number. So first thing we need a starting numbers phase of this game. And then on your turn, there's a couple things that we're going to need to keep track of. Is the last number spoken. And then let's keep reading. Let's see. Consists of considering the most recently spoken number. If that was the first time the number was spoken, the current player says 0. If was first time, speak 0. Okay, easy enough. The current player announces how many turns apart the number is. Otherwise, the number had been spoken before. The current player announces how many turns apart the number is from when it was previously spoken. So, else we're going to speak a last number spoken turn minus last turn this number previous last turn spoken. And then okay. So then the last thing it says is the game ends when the elves get sick of playing it. Their question for you is, what will be the 2020th number spoken? Okay. And then this whole thing is do while less than 2020. You got the idea. Okay. So this is pretty straightforward. The thing that we're going to do is we're going to emulate a game. So we first need to parse some input. Let's grab that sample input as always. That's not the sample input I wanted. That's the sample input I wanted right there. Okay, so we're going to start with the sample input. We're going to parse that into numbers. That's pretty easy. Equals input.ns.components separated by a comma. Okay, that's easy. We're going to split up our numbers. No problem. Then the next thing we need to do is we need to read in these starting numbers into the memory. So how we're going to do that is we're going to iterate over each number. See, this is weird. And this is something why I wanted to pre-solve this, is if you look at it, you can like the natural reaction would be to create some memory, which would be, you know, an int or something like that, right? And then read everything into memory. But the problem is that you actually, on your turn, you are not looking at the next number. You're looking at the previous number, and then you're also looking at the previous time that it was spoken. So, so instead, what we're going to do here is we're going to, well, first things first, we're going to create a struct to keep track of a spoken word, I guess, and this is going to basically keep track of everything that we need to know about every single number that gets spoken. So we need to know the number itself. We need to know the turn that we're on. And then right now that's like all that we need. I guess we need to know how many times it's been spoken as well. So if we change this memory from int to int to spoken word, what we can do is we can read in each of the numbers and add them to memory. And we're going to do that for all except for the last number. Now, the reason we're going to do that is because you need the last number to start your next turn. And I think that's intentionally tricky like that, right? That you need basically 2 steps of memory. You need what happened on the last turn, but you also need the game state before the last turn so that you can compare the two. If you immediately take the last turn and shove it onto the game state, you're not going to know what happened previous to the last turn if it overwrote something. Okay, so for I in number in 0 ... less than numbers dot count minus 1, we're not going to do the last number. We're going to get the number out of our numbers array. So we're going to go through each number. In this case, it's just the first and the second number. And then we're going to say, remember in our memory what that number was, what the value for that number was, and it's a spoken word. We're going to give it the number. The turn is I plus 1. That's kind of gross, but that's just converting from indexes into array into these turn orders that start at turn 1 instead of turn 0. And then the count is going to be just 1 because this is the only time it's been spoken. It doesn't like that. Oh, these have not been mapped to integers. Let's do that really quick. Okay. Perfect. So that gets us our numbers set up. Now what we need is we need to keep track of also what happened on the last turn. And so in this case, we have set up the game. In fact, let's go ahead and convert our comments to real code here. So this is the starting numbers phase. And then we're going to say last turn equals spoken word. And it's going to be numbers.last. And the turn is going to be numbers.count, and the count is going to be 1. So basically we're just saying, all right, the previous turn, if we would have let this loop play out, the last thing, the last turn that would have existed is the last word in the list, and we're going to hold on to it. We're not going to put it into memory yet. Okay, so that is the starting numbers phase. So this is now we're now going to do the do while less than 2020. So for turn number, turn in, let's see, we want numbers.count through 2020. Perfect. I guess technically this is numbers.count plus 1, right? Because we want the turn after, yeah. So numbers.count would be 3, and so we want it to be turn 4. Okay, so that's the do while part. And then this is your turn logic, so what happens on your turn. So we have the last number spoken from your last turn. So we've got that, so check. And then what we're going to do is we're going to say, was this the first time it was spoken? Now, the way that we're going to do that is we're going to say, we're going to get it from memory. So what we're going to do equals numbers sub last turn dot number. So we're going to take the number that was spoken on our last turn, and we're going to look in memory and say, hey, was this number spoken before? Is it in memory? If let from memory equals from memory. If it was, we're going to do something. Otherwise, we're going to do something else. So this is the if was first time part down here, just because we're doing this. Let's see. Oh, this is supposed to be not numbers. This is supposed to be memory. and then that should be optional. Okay, perfect. Okay, so this is our if was first time logic right here. So if this actually was the first time, you want to speak the word 0. So let's do that. So basically the logic for speaking a word is you check to see if it's been spoken. If it has been spoken in the past, then you basically update the count of it. You update the turn that you're on and save it right back into memory. So let's do that now. This is the previous time 0 was spoken. And what we're trying to get is, so it's in memory, what was the last time the number 0 was spoken. And then we want to know how many times it was spoken. That's the part that we need from the previous time. And then we're going to say last turn equals spoken word, and it's going to be 0, which is pretty easy. The turn is the turn is turn. It's this turn that we're going through right here. So that's the turn number that 0 was spoken on, and the count is the previous 0 count plus 1. We've spoken it one more time than it had previously been spoken. Okay, now we've already introduced a problem. We are overwriting last turn before we save it into memory. So let's go ahead and update memory really quick right here before we overwrite last turn, because both of these if statements are going to overwrite last turn. So what we're going to do is we're going to say last turn dot number equals last turn. Okay. So now the last thing that needs to happen is this part of the logic, which is the if it was, I'm going to move this comment here. We need to look at, okay, this wasn't the first time it was spoken, so we need to look at the difference between the two, and that's pretty easy. So difference is going to be equal to the last turn dot turn, because that's the turn count, the turn number, and then we're going to subtract it from the from memory dot turn, or sorry, yeah, the from memory dot turn. Got it. Okay, perfect. Okay, so this will give us the difference between last turn when it was spoken and then when it was previously spoken, which is good to go. And then what we're going to do here is we're going to say let previous count, I guess is what we're going to call it, which is going to take the from memory dot count. So this, because we're doing the same thing here, we're going to increment the number, and then what we're going to do is we're going to say last turn equals spoken word. The word is our last turn dot number. The turn is again our turn, and the count is previous count plus 1. So that'll get us that. Oh, sorry, the spoken word is not last number, it's the difference. That's what you're supposed to speak, is the difference between the last two. Okay, so that should be our logic there. This was spoken before. Okay. And then what you're supposed to do is you're supposed to print out last turn dot number. You're supposed to print out the number that was spoken last. So in our case, let's go 436, and if you look at the example, it's 436. And we can rinse and repeat for these just to make sure. Got 10. So for our sample input, our sample input is this. So we let that run 20 times, and you get 1280, which was the answer we got. Okay, part 1. Now part 2 is pretty simple. Do the same thing, but 30 million times. Luckily, we've got fast computers. I'm sure that there's an optimization here, but computer's fast enough that we can just run it. Turns is an int. So what we're going to do here is we're just going to move all of this logic into this solve problem function. We're going to say solve problem. I did not make it a function. No wonder it's confused. Solve problem turns 2020, and then solve problem, and then I don't remember what their whatever that is. Okay. So all we need to do here is this needs to go to the turns, and then we should be good. So this is no longer do while 2020, it's do while 2020 and then do while 30 million. And it takes a second to run because it turns out 30 million is a big number. So let's have a bite of a muffin, shall we? Now, it's worth noting, if the puzzle input had been much bigger, we would have been in trouble. But it wasn't. It was reasonable. We could brute force it. 651639. Okay, that's the end of today. Hope you guys enjoyed it. Hopefully this helps you solve it and think through the logic of building out this game and following the rules on each turn. All right, if you like these, go ahead and like and subscribe. We'll be doing them every day. We have been so far. And we'll be catching you tomorrow. So stick around. See you tomorrow. Bye.